All right, folks, we're going to look at debugging today. So if you've written other code with other programs, you might be familiar with a console view or some area where when you run the code, you can see error messages. And Arduino IDE has some of that built into it where if there's like an egregious syntax error, it will let you know about it. But a lot of times, the code will compile fine and the bug will actually be in how it runs or how it was written. And that can be harder to track down because there's not a simple way to do something like console log that you might be familiar with, like from JavaScript. So I'm going to show you a couple different ways we can look at debugging with the Arduino IDE. Now, version 2.0 has this great debug feature, quasi-great, but it only works with some very specific Arduino boards that have an SAMD chipset. So if you're not using an official Arduino board, even if you are using some of the official Arduino boards that don't have the SAMD chip, the debug won't work. So I'm not going to get into that since we're using circuit playgrounds. So this code I've got here is just from the examples. If I go into digital button, that's where I got this, copied and pasted it, and then made just a few changes. Looking at our circuit playground, we're going to be working with two important parts, if I can get to focus for you. We're going to be looking at the LED that's built in, that's on pin 13. You can see it says D13 right next to it. Then we're going to use the A button too here, which is upside down, but you can see it says D4 above the A button. Okay, so that's telling us that on pin 4, that's how that button is wired up on this board, and then pin 13 is where the LED is. Pin 13 having the LED is very common across almost all Arduino type boards, but it's not a guarantee. So looking at our code, I've got a constant integer here, so that's a variable that's not going to change, called button pin, and that's where I've added the number 4. I think in the example they use pin 2. Then LED pin is on 13. That tracks. We've got a variable called button state. We're going to set that to 0 initially. Then in our setup, we've got pin mode, LED pin output, so we're telling pin 13 we want it to be an output. It's going to receive voltage. Then pin mode, the button pin 4 is our button. That's going to be an input. So it's going to detect voltage. So, and I've changed this input pull down. So I want the default state of this to be ground, right? So when it's not pressed, the button's off. Okay. In our loop, we've got button state. We're reading the button pin with digital read, so that will update the button state to whatever the button is, pressed or not. And then if the button state is high, we're going to write to the LED pin high. Otherwise, if not, aka if the button state is low, we're going to write low to the LED pin. So that's all this does. I've got that loaded up here so you can see when I push the button, the LED comes on, stays on as long as the button's pushed. When I release the button, it goes off. Very simple. So let's look at some things that could go wrong. Very common thing to miss is a semicolon. So if I do that and try to verify my code, I will get an error. And sometimes the errors are useful and sometimes they're not. So it's saying compilation error expected a comma or a semicolon before void. So this is kind of interesting. So it's telling us there's an error here. This is quite common. It's not that the error is here, but this is where it tried to do something and it couldn't because the line above it had a problem. So if I'm getting an error here, I'm going to look right above it, and that's where I've missed the semicolon. Okay. I can close this and look in the output window here, and it will show, you know, where it encountered the error when it tried to run void setup. And then it's going to tell us again that message expected a comma or a semicolon. Okay, that's one kind of error. Another very common error is missing a curly brace, right? So if I forget to put a curly brace in somewhere, that will give me an error. And Arduino's really nice because if I click near one of these curly braces, it's going to show me or highlight them with a box and show me where it thinks, or where actually that curly brace is paired to. So if I'm going through, I could notice right away, like, that's not right. Like, this should be going to the top one here. And if I click next to this one, I can see I've got a problem because it doesn't highlight. There's something wrong. But let's say I missed that. I was going along and I tried to verify this. Okay. Another compilation error, expected curly brace, closing brace before else. So this time it is telling me exactly where the error is and where that needs to go. Okay, that's great. Let's see. Let's say I forget the last one. This is common too. Expected closing brace at the end of input, right? Yeah, so it's showing me like there should be another one here. We'll put it there. Arduino, you may have noticed, it doesn't really care about white space. It's not like Python. I don't have to have this, you know, tabbed correctly for it to compile and run. However, for legibility, I definitely want to do that. Okay, so then, all right, here's another error that's common, misspelling, right? Spelling counts. Let's say I forget a letter in one of my variable names and try to debug that. I will get this. Compilation button state was not declared in this scope. Okay, so that either means that I'm trying to use a variable outside of its scope, in the scope here, you know, within this if conditional, or I've spelt it wrong. In this case, I've spelt it wrong, so I'm just going to look up there and make sure I've got it spelt the way that I want it to. Okay, and then, okay, so here's a trickier kind of error. When we're working with the Arduino, it has digital pins and analog pins. The analog pins we address like this. A4 is analog pin 4, which if I look at the edge of my board is this one here. You can see the A4 above it. So you might think, well, like the button says D4, so I should put a D4 there, okay? Now, if I run this, compilation error, D4 was not declared in this scope. And here the scope is global. So it's looking for a variable with that name, and there isn't one because I didn't say int D4 equals something. So if I'm working with the digital pins, I just use the numbers. If I'm working with the analog pins, I use A. Okay. What else? Okay, so as you saw, all of this I was doing with just verifying and not trying to upload, because all these bugs I can check in the IDE itself. So that's like a good habit to get into, is to verify before you go to upload, just so you can make sure that the code verifies, and once it verifies, then you can upload it. Let's say I've got code running. It verifies, it uploads, but it's not doing what I want, or it's not doing what I expect it to do, right? Then I have to think about how I can communicate with the Arduino while it's running, right? Because it's a computer. It's doing its own processing. I can't like just tap into that with the IDE like I can with other languages, because it's not running on my computer. It's running here. So I need to establish a communication along the cable between the Arduino and the computer. And I use serial to do that. So serial is a communication protocol that I can run over USB. And to do that, I am going to say serial.get begin in my setup. And I'm using a capital S here. That's important. Serial is a class that has many functions. The dot means, so within the serial class, you call the method function begin. And when I do that, I need to give it a baud rate, so a speed at which to communicate with the computer. This can be slow, it can be fast. I'm going to use 9600, which is pretty slow for a computer. It's quite fast for humans. But if you get into stuff where I'm communicating like in real time with a sensor, I would probably want to use a faster baud rate for that. But for debugging, this is fine. And then after I do that, there's different schools of thought on this. Initiating the serial connection takes some time. So before I get into my loop and start trying to ask the serial communication to do something, I want to make sure it's established. So I'm just going to say delay 1,000 after that. So the Arduino is going to wait for 1 second before it sends, before it goes to the loop and starts sending things to the serial port. The delay function uses milliseconds, so 1,000 milliseconds is 1 second. Okay, we've got the serial communication established. Now if we want to actually use the serial communication, I'm going to look in here and add some things. So one thing I might want to do is, when the button is pushed, I want to know that, and when it's not pushed, I want to know that too. Now, currently I know that by looking at the LED, but let's say the LED is behaving in a curious way. I'm going to put in my conditional serial.print ln, and then I'm going to use quotations and say on. So here I'm saying tell the serial port to print a new line that has the string of characters on. And when I release the button, I want it to print a line that says off. Okay. That's that. Verify. Looks good. Let's upload that. Done uploading. And if I look here, oops. There we go. This button's still working. I don't see anything different here. Let's go to Tools, Serial Monitor. And here we have information. So here we can see the baud rate. This has to match the baud rate we set here. So you want to check that first. The monitor and the Arduino are both communicating at the same speed. We've got this field here where we can send messages to the Arduino if we so choose. And then down here is where we're receiving information from the Arduino. And you can see it's just giving me like infinite offs, right? Because every time this loops, it's saying, is it high? No, send it off. Is it high? No, send it off. Okay. Now if I press the button, you can see it immediately switches to on, right? And it's giving me thousands of these every second, right? So that's how instantaneous it is. So that's nice. So now I can see, like, right, when I have the serial message here off, I know that the code is processing this line, right? Which gives me a good indication that anything in this else statement is happening. Same thing when I see the on, I know this line is running, so I know anything in this section of the conditional is running, or I have a good idea that it is. So this can be very helpful if you're trying to figure out, like, if the LED wasn't turning on, well, like, is it even getting to this section of code, Okay, this is how I use this debugging method. Now I'll show you one more thing. Let me get rid of this and this. Let's say I'm just curious about the button state, right? I want to know, I'm saying like high and low and all this, but I want to know like what is the button state actually? What does it look like? So I'm going to say serial dot print line button state. Okay, so I can take a variable and put it into print line, and it will print out whatever that variable has within it. Now, another thing I can do with the serial is I can say print. That will print this data to the serial port sequentially. So instead of having my scrolling go vertically, I'll start having scrolling go straight across. And it won't put spaces between anything. I'll just get like an endless stream of OFF, 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 which can be very hard to read. So typically you'll use a print line. You can get into situations if you're checking like multiple variables where you want to delineate things with tabs. That's where print might be more useful. But let's check this. Okay, and now this looks different, right? It says done compiling, but I can go back to my output, make sure that worked. Serial monitor, upload. There we go. Okay, and we're back to the serial monitor, and we're getting all these zeros. Now I press the button, and we get ones, right? So that's what I would expect. The 0 equals low, the 1 equals high. If we remember from our coding rings, right? 0, low, false, all the same. 1, high, true, all the same as far as the Arduino is concerned. And then the one other thing I'll show you is this is nice, being able to see the numbers here. But sometimes you're working with data that's not 1 or 0 or on or off or stuff like that. Maybe you're working with analog data that can be a range of values, which we'll look at a bit in the future. So it can be helpful to see these things as a graph sometimes. So if I open the serial plotter, now I can see that value that I'm printing, and I've got a blue line at 0. And when I press the button, it goes up to 1. And you can see the scales changing very quickly, and every now and then you're seeing that blip. And these weird spikes every now and then, right? That's just noise. So that's how I can use the serial monitor to help with debugging. If I had other values, I could look at the, I can turn off on and off values up here. I can stop and run the serial monitor as well. And these X boxes just clear the data that's there. So hopefully all of this is useful to you when you are trying to debug your own projects.